Greetings, fine physics folk. On Monday, we went and looked at situations of a whole system moving through time. Today, I just want to add one, maybe two small little additions to that. We're still going to be working with the same equations. We're still with the same concepts of energy converting back and forth between potential and kinetic. And as always, I think the roller coaster is really the great example of that. I know that I've said this before, but again, when looking at the metal roller coasters, they just don't have the same thrill. There's just too much safety involved. There's external forces that could go ahead and stop it when necessary, but you do still have, even in those advanced roller coasters, transfers between the potential energy and kinetic energy. When you start, they either lift you up a big hill, or there's a giant spring. Oversimplified, it's like hydraulic pressures, but essentially like a spring that springs you forward, gives you the energy. And once you have that energy, that's the energy that catapults you through the whole ride. So you had a homework assignment on Monday that kind of looked like this. And you're probably wondering, okay, well, we had it already, so I don't see why this is any different. Well, this is going to be like number 3 of the homework assignment that we had on Monday, the roller coaster one. But there's one difference. I'm not giving you the mass. You have to solve for it. Just to reiterate what we're looking at. These are 4 different points in time. It's the same object rolling down a hill at 4 different points in time. So if you don't have a mass, what do we know? We know that the mass and the total energy never change. Well, we know the total energy never changes. It's just converted back and forth between PE and KE. And we know that if an object is rolling down the hill or falling, its mass isn't changing. We did how mass changes earlier in the year, and nothing's going into, nothing's coming out of the object, so its mass really isn't changing. So the way these problems work is you are going to jump around. You have to go ahead. You cannot do it in order. I cannot just start with spot 1, spot 2, spot 3, spot 4. You have to jump around. So this is what I'd recommend you do. The first thing you need to get is the mass. We have 2 equations. PE equals mgh, and we have KE equals 1/2 mv squared. These are our 2 equations. This is what we have to work with. Ooh, mouse isn't working. Oh, I know why. Sorry, let me just quickly. I know what happened. I was not on a good reflective surface, and the light from my mouse wasn't catching. There it is, much better. So here are 2 equations. We have these 2 equations, which are going to guide all the math that we do. So technically, there's no new math. We're just applying it in new ways. All right, spot 1, spot 2, spot 3, spot 4. One of those spots we can use to solve for the mass. Let's look at spot 1. All right, I got a PE of 650, but I don't have anything else. Let me give you a hint. If you're going to solve for a variable, mass or total energy, you need at least 2 things in this little chart filled in. Because there's only 1 here, I know I'm not going to use spot 1, and I'm not going to use spot 4. So the question is, I have to use either spot 2 or spot 3. Okay, let's look at spot 2. I have a PE and an H. Oh, I get it. If I have a PE and an H, I always know the G. That's gravity. That's 10. Check it out. This is what I can do. I can say 300 equals M G H. 300 equals 50 M. You divide both sides by 50, and you're going to get a mass of 6 kilograms. So what we're saying here is that the mass is 6. We know the mass is 6 for every single spot. The mass is going to be 6 here. So, I mean, the mass is 6 here, 6 here, 6 here, 6 here. So now that we know the mass, we can go ahead and solve as if it was a problem from Monday. Well, was it always confused with the problems from Monday? Well, that's okay. Let's figure it out. Now that we got the mass, the next thing that we need to get is the total energy. These are the two things that you need to get first. You need to get the mass, you need to get the total energy. Start with the mass, then the total energy. To get the total energy, I need to get both the PE and the KE. Okay, is there a spot that has PE and KE? Let's check. Nope. 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 And nope. All right. Because I know if I can get the PE and the KE, I can add them up to get the TE. But here's my question. Is there a spot where I can solve for both the PE and the KE? Well, spot 1, I have the PE, no way to solve for the KE. Spot 2, I have the PE, I have the height, but I don't have the KE and I can't solve it because I don't have the velocity. Spot 3, I have the KE. Check this out. I have the KE, and with this height, I can solve for the PE. Let's do it. Let's see how this is going to work. So I have a height of 4.2. I'm going to, let me go ahead and actually show you PE. We're going to solve for this PE. PE equals 6 times 10 times 4.2. Sorry about that. I'm just having some issues here, but that's okay. The PE is 252 joules. Okay. So, now what? I can add the PE and the KE that I got right there. So I can do 252 plus 490, and I can get a total energy of 742 joules. Sorry, just technical issues working this out. Okay, but hang tight. Let's just recap what we did. We looked at all the spots. We found the spot where we could solve for the mass. We got the mass of 6 kilograms. Now I know what the mass is every single time. Then I looked at a different spot, used the mass to solve for the missing PE, added it to the KE, and now I got a TE. Once I got that TE, I can now fill in all the other blanks. What do you mean? Well, I know that at every spot PE plus KE equals TE. So I can always just do 742 minus 650. That's going to give me KE here of 92 joules. Because PE plus KE is TE, every single spot. 742 minus 300 is 442 joules. Every spot, every PE and KE in this whole problem has to add up and equal to 742. Okay, wait a minute, Bazzuto, the very last one. I don't have a PE or KE, but I do have a velocity. So I can use the KE equals 1/2 mv squared. And I'm sorry, one of the reasons I'm pausing is I realized I wrote the wrong number here. This was supposed to be a 15, and that's my bad. I'm going to own that one. That's supposed to be a 15 out of 16. But I digress. So when I go ahead and plug the 6 and the 15 in, I get a KE of 675. I'm just plugging it into that equation. I'm not going to show every step right now, because this video would take forever. I subtract 742 minus 675. I'm going to get 67. There we go. And what I can do is I can use these energies to solve for the heights and velocities. We've done that before. We have done that before. I will do one example. I won't do them all. I know these problems are long. I know they may seem tedious. But there is a reason I spent all the time going through the math so that you would know how to do this. So let's look at spot 1, where it says PE equals MGH, 650 equals 6 times 10 times H, 650, I'm out of space, but you get the idea, equals 60H divided by 60 is 10.83 meters. And how would I solve for the velocity? Okay, let me show you. This is how you solve for the velocity. KE is 1/2 mv squared, right? So if I have a KE of 92, I actually do want to go through this one because I noticed in a lot of people's works, we still mess this one up. 1/2, the mass is 6, and the V is what we're looking for. This is what we do. We're going to take half of 6. So it's going to become 92. I'm just going to put it over here because I'm out of space. 92 equals 3V squared. To get the V by itself, you have to divide both sides by 3. Okay? So 92 divided by 3 is 30.6 repeating. So I'm going to say 67 equals V squared. But I don't want that, so I got to square root that, John. And when I take the square root of that, that's how I get my velocity of 5.54. And here's a way to check your work. As you go down, as this ball rolls down the hill, the height should be decreasing. What do you mean by that? So Bizzuto, spot 1, where it's the highest, it's 10.8. Then the next highest is 5, then 4.2. Oh, this makes sense. As it rolls down the hill, the height is decreasing. The velocity should be increasing because as it rolls down the hill, it speeds up. So if it starts off at 5.54 meters per second, ends up at 15 meters per second, it's increasing, and every spot should fit that pattern. Let's look at another one. Okay. Your questions are really simple. That's kind of why I wanted to go through this. I realized I may have put too much practice. I could imagine a whole class period just going over this one problem at the board, but I want to make sure that we really get this. We have our 2 equations. We have our 4 spots again. It's the same object. Let's just say this box is falling. What is the first thing we have to get? We have to get the mass. I know I can't use spot 1 or spot 4 for the mass because they only have one piece of information. I have to use spot either 2 or 3. Oh, okay. I can't use spot 2 for the mass because Ke equals 1/2 mv squared. Ke doesn't relate to h, but I can use spot 3 for the mass. So this is what I'm going to do, because I have all the variables except mass in this equation. So Ke equals 1/2 mv squared. And I absolutely want to show you this math, because this is going to be confusing. I'm going to give you some big numbers today, because I feel like it, because I know you can handle it. I'm just writing the equation in. I'm plugging in what I need. All right. The square only goes to velocity. One half m 100. Okay. So I'm going to take half of 100. 5250 equals. So when you have the three variables like this, you can do them in any order. So if I take half of 100, it just becomes 50m. Then I divide both sides by 50. And I believe, if I've done this correctly, yes, I should have a mass of 105. So I now know the mass. Questions on that? Okay. I'm going to keep it moving. I'm going to erase all that work because I need the space. I need that space. Goodness, I need that space. All right. So what's the next thing you need to look for? Once you get the mass, you've got to solve for the total energy. Well, how do I solve for the total energy? I have to find a spot that has a PE and a KE. Again, it's not going to be spot 1 or 4. Don't have enough information there. Can I use spot 3 again? No, because there's no way I can get the PE without a height. So let's look at spot 2 this time. Ah, spot 2. I have a KE. Oh. And what I can do is, now that I have the mass, I can solve for the PE. I wasn't able to do this before I got the mass, but now that I have the mass, I can go ahead and plug in PE equals 105 times 10 times a height of 9. And I can literally type that in my calculator and get 9,450. That's the PE. So 9,450. Awesome. So what are we going to do now? Let's get the total energy. Let's add it. Let's add it. What are we adding? Bam. We have the PE and the KE there. So I'm going to do 9,450 plus 1,500 equals 10950 joules. That's the total energy at every single spot. So we can do a lot now. We can fill in this. We can fill in this. Let's do it. I'm going to take 10,950 minus 9,000, and that's going to equal 1950. I'm going to do 10,950, the total energy, minus 5,250. We get 5,700. And for this first one up here, what I can do is I can use the height to solve for the PE. Let's do it. So I hope you see, you just use these equations again and again and again in different ways. So the potential energy is 10 0.500, and then I minus from the total energy. So the kinetic energy here is 450. There we go. Because at every spot, the PE and the KE add up to this number, the total energy. And now this is just the math that we did before. For spot 1, I could use the I could use the KE to solve for the velocity. I have a mass, I can do that. In spot 2, I can use the KE to solve for the velocity. In spot 3, I can use the PE to solve for the height. In spot 4, I can use the PE to solve for the height. I can use the KE to solve for the velocity. It seems redundant, I understand, but the more practice you do on this, the better you will get. I'm not going to solve all those out. If you need help doing that type of math again, I am here, but we have practiced that. We have done examples like that, and that's kind of why I wanted to spend the time learning how to solve for all those variables before we got to this. I hope that makes a little bit more sense now. So, in order to find the mass, you need to find a spot that has. So this, in case you're like, I don't know what to start. If you want, I need a stepwise procedure to start, because your homework this today is going to be 2 fairly large roller coaster problems. They each have 5 or 6 steps. I can't remember offhand, but they're going to have a bunch of different spots, and you'll have to jump around. So the first thing you have to do is find the mass. So in order to find the mass, you have to find a spot that has either. You can look for either of these 2 things, PE and H, or KE and V. Once you have a spot that has those 2 values with numbers, not blanks, not question marks, not anything. If you have a spot that has those 2, you can use that spot to solve for the mass. And remember, the first step is to find the mass. Once you have the mass, you can then solve for the total energy, the TE. Once you have the mass, you can now look for a spot that has either the PE and the KE, the PE and the V, the H and the KE, or the H and the V. If you find a spot that has any one of these, you can use these to solve for the TE. How can I do that, Pizzuto? PE plus KE is TE. If I have a PE, I can use a V to solve for a KE. And then I can do PE plus KE is TE. Okay? If I have an H, I can solve for a PE. If I have a PE and a KE, it's a TE. And this is the trickiest one. If I just give you an H and a V, you can use the H to solve for the PE, the V to solve for the KE, and then it solves for the TE. First you find the mass, then you find the TE. So that's it. We're going to just have more practice on this. I want you to know a quiz is coming, probably next week. When we do that, you'll lose access to the other websites on your computer. So I'll ask you in advance to make sure you have your notes written down on this so that we can, I can really see how well you can do this. This is a very important concept, so it's coming. I have office hours today, and again, if you have questions, ask them. I'm here to help. Good luck, you guys. We're getting through it.